You know, when you think about the future of flight, you probably picture wind tunnels and supercomputers, right? Well, what if the real secret isn't in a lab at all, but out in the wild? Today, we're going to dive into a pretty amazing experiment that does exactly that.
And that brings us to the big question, right? Building and testing even one new aircraft is mind-bogglingly slow and expensive. So how in the world do you innovate at a massive scale? The answer, as it turns out, is to stop building things in the real world and start building them in an entirely new universe.
Okay, so before we jump into this virtual world, let's talk about why we even need it. What's so broken about the way we've been designing aircraft for decades?
Well, here's the problem. The old school way of doing things, building physical prototypes, is a total bottleneck. And it's not just about the money and the time. It actually puts a cap on our imagination. We tend to build slight variations of what we already know, which makes those huge revolutionary leaps, well, almost impossible. And this is where things get really cool. The solution they came up with is what they call a synthetic design universe. Think of it as a massive digital sandbox where you can dream up hundreds of new aircraft, fly them on realistic missions, and even crash them, all without ever bending a single piece of metal.
All right, so how on earth does a lab like this actually work? Well, it all starts with a totally new way of thinking, a new language for design, you could say, one that's been in development for millions of years through evolution.
Here it is, the core concept, and it's brilliant. Now, the key thing to get here is that this is not about making a drone that looks like a dragonfly. It's about taking an animal's special ability and translating it into a concrete engineering trait. It's less like copying and more like creating a whole new vocabulary for building things.
Okay, check this out, because this is a perfect example. You take the cheetah, famous for that explosive burst of speed, you abstract that ability into an engineering trait, which they call lift burst power. In this virtual world, that translates directly into an engineering choice, like adding a supercapacitor to give the aircraft a short, powerful boost for takeoff.
Let's do one more, just so this really clicks. Think about the osprey. It's an absolute master at handling a swinging payload, like a fish it just caught. That incredible ability becomes the engineering trait payload damped. In the design lab, that might mean adding a special damped mount that keeps the cargo from swinging around in rough air.
See how it works?
And believe me, this design team, it is stacked. You've got the insane lifting power of the harpy eagle, the dragonfly's ability to just shrug off a gust of wind, the albatross's pure efficiency, even the tiger's ruggedness. Each animal brings a unique skill to the table, creating this incredible toolbox of design options.
Okay, so you've got this awesome design language, this whole menagerie of traits. That's cool and all, but putting it to the test, that's a whole different story. And yeah, this virtual proving ground, it turned out to be absolutely brutal.
Get this, just 32.8%. That's the success rate. That means almost 7 out of 10 of these brand new bio-inspired designs completely failed their missions. This wasn't some walk in the park. This digital world was designed to find every single weakness.
So what went wrong? I mean, where was the weak link? Well, this chart tells the whole story, and it is crystal clear. An absolutely jaw-dropping 73% of all the failures happened right at the beginning, during the takeoff climb. Just getting off the ground was, by far, the deadliest part of the mission.
And that killer has a name: power saturation. To put it simply, the motors they hit a wall. They redlined. When the aircraft was trying to climb and screaming for more power, the system just couldn't deliver. It maxed out, and mission over.
But out of all that digital wreckage, a few champions did emerge. So let's do an autopsy on a winner. Let's look at the anatomy of the top-performing design and figure out what it takes to actually survive this gauntlet.
So here it is. This is the DNA of our champion. It's not one animal, it's a hybrid, a mashup of traits from 5 different animals, all combined to create something totally unique and seriously effective.
So what's the magic here? Why did this combination of animal traits work so well when so many others failed? Well, it wasn't about being the strongest or the fastest in any single category. It was all about having the right combination of traits for this specific difficult mission.
Okay, this is the magic right here. This is where it all clicks. You remember that #1 killer, power saturation? Well, the cheetah's lift burst power, that supercapacitor, it knocked that problem right out. The dragonfly's gust rejection made it rock solid in turbulence. Inspiration from the tiger led to using lightweight tendon cables, which let it carry more than 3 times its own weight. And the eagles inspired a central talon design that kept the payload right under the center of gravity, so it barely swung at all. You see, every trait had a purpose, and together they worked.
So okay, we've got a winner. We've dissected it, case closed, right? Well, not exactly. As you might have guessed by now, finding one amazing aircraft was never really the point of all this.
And this is maybe the biggest takeaway from the whole experiment. The journey was more important than the destination. This wasn't a contest to find a single perfect vehicle.
The real goal was to build a system for learning, a way to explore thousands of ideas, to fail fast and cheap, and to really understand the complex trade-offs you have to make, all before you even think about touching a piece of hardware. It's a system for getting smarter, faster.
And honestly, this quote from the folks who ran this whole thing, it just sums up the entire philosophy perfectly. The real win isn't a final design. It's the ability to ask better questions much earlier in the game.
And that really leaves us with one final big question. This idea of building a synthetic universe to test, fail, and learn at a massive scale, it could be applied to just about anything. So think about it. If you could build your own virtual universe to test anything, what massive problem would you try to solve?